Biochemical tests for sugars. Specification reference is biochemical tests using Benedict's solution for reducing sugars and non-reducing sugars, and iodine or potassium iodide solution for starch. All sugars can be classified as reducing sugars or non-reducing sugars. The test for sugars, you use the Benedict's test. The test differs depending on the type of sugar you're testing for, and the Benedict's test goes from a blue colour to a brick red colour. So, reducing sugars. All monosaccharides and maltose are reducing sugars. And reduction is gain of electrons. So, reducing sugars can donate electrons to other things, like Benedict's, which is alkaline copper sulfate. So, the reducing sugar plus Benedict's plus heat equals copper oxide, which is a red precipitate. So it's that red precipitate that gives it its positive brick red colour. So as I said, reducing sugars are all monosaccharides and some disaccharides like maltose and lactose. So what you would do is add Benedict's, which is a blue colour, to a sample, heat in a water bath, and if the test is positive, it will form a coloured precipitate, which is solid particles suspended in the solution. And the colour of the precipitate changes. So if you heat it with a sample and it's negative, it will stay blue. If it's got some sugar, it might go green. If it's got a lot, it might go orange. If it's got a real lot of sugar, reducing sugar, it will go to a brick red precipitate. So the higher the concentration of reducing sugar, the further the colour change. And you can use this to compare the amount of reducing sugar in different solutions. A more accurate way of doing this is to filter the solution and weigh the precipitate, or to remove the precipitate and use a colorimeter to measure the absorbance. So, test for reducing sugar is blue Benedict's reagent. If it's positive, it goes to an orange or brick red precipitate, which means reducing sugar is present. And as I say, you can use a semi-quantitative method to estimate the amount of sugar in the sample. So if it goes green, it means there's a very low concentration of reducing sugar. If it goes orange, there's quite a lot. If it goes brick red, it's quite a high concentration of reducing sugar. You can also dry and weigh the precipitate to measure the amount of reducing sugar present. So now we need to look at a non-reducing sugar. So if the sample tested with Benedict's is negative, you heat the sugar solution with Benedict's reagent, and it would be negative. There will be no colour change. So the next step is to break down the non-reducing sugar into the reducing sugar. So you would heat the sample with hydrochloric acid, which hydrolyzes the disaccharides into monosaccharides. Then you would neutralise it with an alkali, because the Benedict's won't work in acidic conditions, so you need to neutralise it. Then you would add the Benedict's reagent, you would heat the sample, and you would get an orange or brick red precipitate. And the reducing sugar that is present has come from the non-reducing sugar that was hydrolysed. And if there was no colour change again, the original sugar was not a non-reducing sugar either. And then finally, you need to know the test for starch. So starch, you add iodine solution to the sample, and it goes a blue-black colour. And if it stays brown, it means there's no starch. And the iodine test is semi-quantitative and can therefore be used to estimate the relative amount of starch in a sample. So if it goes a really deep blue-black, that means there's a lot of starch. If it only goes slightly blue, it means there's a bit of starch. If it's